Welcome. Let's look at further work. What are we going to tackle this time? We're going to look at encoders and decoders. All right, fine. We'll start with the basic. What is an encoder decoder system anyway? All right, let's have a system. All right, our system is obviously a digital system. Therefore, this digital system here needs to be fed by the input gadgets, and this is where the encoders come in. This is where the encoders come in. The input, this is where the encoding comes in. All right, so we have our encoder there. All right, now that encoder will feed the system. Okay, system will do whatever it wants to do. Now the output gadgets are going to do the decoding for like the human user interfaces, interfaces. Basically, for us to be able to read what's going on there, we have to have a decoder system there. All right, that is the decoder, and this is obviously our output here. All right, so what I'll do is I'll tackle the encoders first. So let's go and see how. Let me put this on the side, and basically as a reminder I'll leave it there. Now let's check encoders. For instance, what are encoders going to do? We are going to have our outputs, our inputs being what? Let's say we are going to have X inputs. Let's have that input for the 0, input for the 1, input for the 2, for the 3, for the 4, for the 5, for the 6, for the 7, for the 8, for the 9, because this here is going to be 0 to 9. This is our decimal system, right? So now what we then do is, I think it moved a little bit too much to the one side. Now this system here is going to have to be changed into one of the codes, encoders. So let's start there with the this is decimal, né? So we're encoding decimal here. So it's going to be, the output here is going to be a BCD output. So how many forms of BCD do we know? We have, let's start with the 8421, the basic BCD, 8421. Now 0 does not drive any of these guys, okay? But the 1 needs to drive that one, okay? The 2 needs to drive the 2. The 3 needs to drive the 1 and the 2. So what do you notice here? So when I've got 0, none of the gates will engage. When I've got a 1, that 1 should be able to drive that gate. But a 3 should also be able to drive that gate. So it's either a 1 or a 3. So these are alternatives. So this here could be a 2 or a 3. So these are alternatives. So if it's alternatives, this or that, it means therefore we have what call this OR case there. Now the 4 obviously will be driven by that and alternatives that need a 4, such as a 5. But if 5 is 4 and 1. Okay, now you've got 6, which will be again a 4 with a 2. Okay, so that will go to 2. It's fine. I wanted to do it here, but no, I'm done. That will be, so 6 is a combination of 4 and 2. What is 7? 7 is 4, 2 and 1. So now I'm going to need to move this a little bit. Let me select it. I'm struggling here. Yeah, I just want to move this one here a little. Okay, and then that one there can come there. All right, I want to. Okay. Okay. Now, so now we're looking at 7, which is 421. Therefore, we need the okay 4 also. Okay, so if I engage any of these as my inputs, let's say it's a keyboard, and I enter any of those from 0 to 9, the corresponding gate, okay, obviously 0 will drive nothing, but the 1 will then drive that gate, and everything else will be 0. Remember that when you engage one, it deselects the other ones. All right, they cannot be engaged at the same time. So if it's going to be one at a time. So the 1 will mean nothing here, nothing on the what, on the 8, nothing on the 4, nothing on the 2, only the 1. All right. Likewise, if I pick any other one, let's say 6, it will be 4 and 2. So 8, it will obviously be just 8. Whereas 9 will be 8 and 1. All I'm doing here is reading the count. We know 9 is it's going to be a combination of 8, no 4, no 2, and a 1. All right, so this is basically our encoder. Our input is the 0 to 9 decimal. Okay, this is a decimal input. It's an encoder, so our input is a decimal. All right, and then our output there is a code, and that code there is the BCD. This is our decimal input, and we've got our BCD output. Remember, with the 8421, that's the only one we can actually not have to say 8421. All right, it's the only one that we can just call BCD. So this is basically one of our this is basically our basic encoder. Now I'll look at a second encoder. All that I'll do now is change the inputs because they won't be the same for this different one. Oh, no one, wrong one. I want that one there, and all I do is remove these guys here. Now what I want to do is I want to do the 2421. The 2421, all that changes there is that this becomes a 2, and this is 2421 BCD. All right, now with that one there, you know that this is the 1 is simply the 1. Nothing changes on that part. Okay, and then the 2 is the 2. Lower order 2, there's 2 2s. So for numbers that are below 5, it's the lower order 2. This is the MSD, and this is the LSD. Probably I should have indicated that also with what, with the 8421. But in any event, 8421, it would be like that. I mean, that would be the 8 would be the most significant. But maybe I should have included in that sketch there before I changed everything there. Maybe I should have said for the 8421 there. Let me put this back. All right. Maybe I should have said there. This is our MSD for the 8421, and this is our LSD. All right. So we should indicate which one is the MSD and which one is the LSD. Now we come and say, okay, let's remove these guys here, and let's tackle the 2421. With the 2421, all that changes is that output there, it becomes a 2, and now we need to specify it's a 2421 whereas it was unnecessary for the 841 because BCD normally, without actually identifying a specific one, would actually mean the 841. So if I wasn't specific, if I didn't specify which one, then you'd assume the 841. But in the case of the other ones, you have to specify. So that's why in this case now, we have to say 2421. And then with the 2421, we know that 1 does not change. It's still the 1 coming in there. Okay, 1 didn't change. The 2 does not change. We use lower order 2s for numbers that are what? This one here is for numbers that are what? Are below 5. This is below 5. Okay, that one is for the number that are above 5. So you prefer, first preference will be what? I wanted to say below 5. This is greater than 5. I made a mistake there. This should be below 5. If your count is below 5, we use this 2 here, all right? But if your count is above 5, then we use the other 2. Okay, for ones that are below and above 5, so you need to know which one. So now 2 is below 5, so we use that 2. 3 is 2 and 1, and 3 is below 5, so it needs this. What am I saying? 3 and 1. 3 is 2 and 1. So there is 3 is below 5, so we use that one there, and we need a 1 for it. And the only other one is that one there. Okay, now 4 is, we have a 4, so the priority is the value itself. We've done this when we're doing the codes. 4 will be the 4, all right? And then the 5 is both 2s because it is neither above 5 or below 5. So it will be the 2 2s. So 5 is 2 2. 2 2 1. And then the 6 now is the 4 but with the higher order 2. Oh, what am I saying? The 6, and I'm still on 5. The 6 is the 4. 6 is above 5, so it's 4, but the 2 is the higher order 2. Then 7 is again 4 2 1, so which 2 is above 5, so it's the higher order 2. So it's 4 2, in this case it's 2 4 1. All right. All right. Now then obviously we have 8, which is both 2s because that's the only way we can get 8. Two 4 2 1, and then 9 is everything. 9 is 2 4 2 1. Okay, so notice how lines cross here. So when you show that, when you want to indicate that there's a connection, you must have to put that dot there. Otherwise, it means there's no connection, right? So lines, because lines cross, so the difference between that and that is that this one, for instance, is not connected there, but it is connected there. Okay, the 8 is not connected to the 9 line, it is connected only to the 8 line, that 4 there. All right, so now you have to be careful about that there. All right, so this is an example. We've done 2. The input didn't change, but sometimes questions get tricky. Okay, and the questions say, all right, give us a 3-bit decoder. If it's a 3-bit decoder now, obviously it would have to be the counts can only go up to a certain count. For instance, it's a little bit tricky. You can't do a 3-bit decoder with a 2421 because the count 7 will still need that guy. The lower counts will still need that guy. So you need all of them in the case of us. So 2421 can never do can never do 3-bit counting. But if you have an 8421, your count can be just 1 bit, which is going to be obviously what? The 1 bit is going to be 0 and 1. It can be 2-bit, which means the counts what? 0 1 2 3. It can be 3-bit, which means what? Which means 0, 1, 2, up to 7. So you need to be careful when you do your questions. Now, the first one that we did, this is the 2421. Any other one, as long as we know the count. How do we know this? We know that this here is 0, 0, 0. So that's why everything here is not connected to anyone there. All right. But this one is 0. Let's do the count there. 0, 0, 0, 0. Hence, there is no gate that is driven there. But for that one there is 0, 0, 0, 1. So you can see it is driving the 1. If I jump to 3 there, let's go to 4. 4 is 0, 1, 0, 0. Hence, it drives the 4 gate. Let's take 7. 7 is 2, 4, and 0, 1. So 2 plus 4 is 6, 7. Hence, you've got the higher order 2, the MSD, higher order 2, and then you've got the 4, then you've got the 1. So it's easy. Now you know 9 is everything. 2, 4, 2, 1, hence the 9. So all you do is basically know your count, and encoding will be very easy. All right, so I want to deal with what call this with the decoder, with only the encoder today. I will only do these basic decoders, but then now as long as it's changing from decimal to any code, that should be easy enough. They are much more we are going to deal later with much more intense encoders. For instance, when we are dealing with encoding from one code to another, like let's say for instance from 2421 to gray code, for instance. All right, that is also an encoder. So from one code to another. All right, so even though the basic encoder is from decimal to what call this, to whatever code that you want, usually PCT codes, but we also tend to have intercoding, which is from one code to another code. So we will deal with that later. For now, I think that to be the good intro to encoders. Let's see if we can look at decoders next. As in, hopefully you're enjoying this. Let's meet next time.